elevation. Steady winds from the Atlantic blow up over this crest over to the Pacific side of the country, producing huge energy.
If you are interested in learning more about capturing energy from the wind, I'll show you how to construct a model windmill and how to set it up to actually calculate its power output. Here's how to construct this windmill. Start with a 30 centimeter square of stiff card. Bristol board works well. Next, draw the diagonals on the card, corner to corner. Then, with a compass, draw a circle at the center of the card. The circle has a radius of 3.5 centimeters. The center of the card is where the diagonals intersect. Next, draw 2 centimeter arcs centered on the corners of the card. Just set your compass to 2 centimeters to do this, then draw them as shown, each one to the left of the diagonal lines. Now make a mark at the center of each of these small arcs. We are going to use a hole punch to punch holes in each corner of the card at these marks. Next, push a nail or pencil through the center of the card, making a hole where the diagonals intersect. Now cut along each diagonal from the outer corner, stopping at the circle. When the cutting is completed, gently curl the blade pieces with the holes in them to the center. Secure the 4 blade tips to the center with a 3/16 by 3 inch bolt. Use a washer and nut to hold this assembly together. Next, you need 2 pieces of plastic tube that will fit over the bolt. I use some pieces of plastic hose similar to aquarium air supply tubing. One of these tubes is 1.2 centimeters long, the other one is 1.7 centimeters long. In this next assembly, drop a washer on the bolt, and then the 1.7 centimeter tube, and then another washer. At this point, you need to construct a base for the windmill. I used 2 pieces of wood, a large one for the base and a long one attached as an upright. You need to create a hole in the upright, just slightly larger than the diameter of the bolt. Make sure the hole is high enough so that the blades don't hit the ground. If you need power tools to make this hole, make sure you have professional help. Push the bolt through the hole, then a washer. Now thread a nut onto the bolt, leaving the windmill free to turn. Now finish the windmill by adding another washer, then the 1.2 centimeter plastic tube, followed by another washer and a nut. Use pliers or wrenches to tighten the nuts against the plastic tube. This plastic tube becomes a pulley. You may have to adjust the style of your base or the shape of the card blades so that the blades don't hit the upright when turning. The next video demonstrates how to calculate the power output of your windmill. If you've constructed one of these model windmills from our website or as part of one of our workshops, I'll show you how to test your windmill to determine its power output. Power is a measure of the rate at which a machine does work. Let's make this machine do some work. Start by wrapping a string around the pulley on the back of your windmill. 2 meters should be lots. Create a small load and measure the force needed to lift this load. I've just used some pennies here and a paper pouch to create this load. And using a Newton spring scale, what do we have? Looks like 0.9 newtons. 0.9 newtons is the force needed to lift this load. Connect the load to the end of the string and you are ready to make your windmill do some work. I mounted my windmill on the top of a stepladder and lowered the load to the ground by unwinding the string. With the load on the ground and the windmill blades blocked, we are ready to start our test. To calculate work, we need to determine the distance that the load moves. With a measuring tape, I determined the distance from the ground to the windmill to be 2.5 meters. I used a block to stop the windmill blades from turning. As you can see, when I removed the block, the blades started to turn, lifting the load. You may recall our load is 0.9 newtons. Our windmill must produce at least that much force to lift this load. With our load at the top, we are ready to calculate work. To determine work, multiply force times distance. Force produced was 0.9 newtons. Distance, 2.5 meters. Multiplying 0.9 newtons times 2.5 meters gives an answer of 2.25 joules. Joules are the units of work. Our windmill completed 2.25 joules of work. Power is the rate at which a machine does work. The watt is the unit of power. 1 watt equals 1 joule per second. To calculate power, divide the work done by the time it took to accomplish that work. Starting a stopwatch when the windmill starts to lift, we can determine the elapsed time. In this example, the windmill completed lifting the load in 9 seconds. We know from our previous calculation that our windmill produced 2.25 joules of work. Power equals work divided by time. In our example, we divide 2.25 joules by 9 seconds, yielding an answer of 0.25 watts. Our windmill has a power output of 0.25 watts. Do you think a stronger wind would affect this power output? 0.25 watts is a very low power output. Your toaster at home is a 1,000 watt device. It would take 4,000 of our small windmills to create enough power to run your toaster. Large windmill farms like these turn generators to create electric energy from the wind. Windmills like these create enough power to run whole villages. Even though wind is a clean source of energy, there are still concerns, including safety for migrating birds, aesthetics, and noise, problems that engineers and scientists are working to resolve. More energy projects can be found at our website, hylaroad.com. Follow the projects link.